layer over the top of these things that were cut flat.
Yeah, so you can see the striation. So when it comes to machining, you're talking about...
This one shaft proves so many things. The Queen's Chamber passage.
Because the penetration rate of the drill is 500 times more efficient than a 21st century drill.
But when you actually look at the evidence with an unfiltered lens,
or the distance between each groove is between 2 and 3 millimeters. So again, actually this stone here is basalt, which is about 6 to 7 on the Mohs scale out of 10. And where my finger is going, we see that it's actually not a straight line, but an arc.
there is a single discovery that proves that the current narrative of mainstream archaeology is wrong on the Great Pyramid of Giza. Why? Because no human can fit inside this hole to carve it. It is simply impossible. And all other techniques are just plain illogical. And when that discovery is put into the context of other similar contradictions, it shows that Egyptologists have either done a sloppy job at analyzing the true potential of ancient Egypt, or that there was an intentional, deliberate attempt to minimize the achievements of what the ancients could do. And that is directly in line with the modus operandi of archaeologists, specifically Egyptologists, over the last 2 centuries. Because once your field of study has been proven to be rife with lies, especially on one of its most important aspects, what's one more lie to cover the true potential of the most sophisticated civilization in ancient history? In 1993, German engineer Rudolf Gantenbrink ventured into the bowels of the Great Pyramid of Giza to probe a mysterious, unexplored shaft in the Queen's Chamber. Unlike the 2 shafts in the King's Chamber, known to open to the outside, these angled passages plunged only 10 feet into solid masonry before vanishing without explanation. Driven by obsession, Rudolf built a toy-sized robot, no bigger than a child's toy, to slip into the narrow, 8-inch square corridor, armed only with a tiny camera and a dim light. What happened next was totally unexpected and further complicated the mystery of how they built the pyramids and why. But it also complicated how the ancient Egyptians, the Kemetu, would have built this impossible passageway. At the point, he expected the robot to grind to a halt. Something appeared on the camera that made no sense. The shaft didn't end. It tilted sharply upward at a brutal 40-degree incline, revealing a vast hidden section of the pyramid that no human had laid eyes on for 5,000 years. The little robot crawled for what seemed like an eternity. For 90 yards through pitch-black stone, they were treated to an immaculately straight set of walls. The craftsmanship was so masterful that they couldn't tell the intervals between the different stones. Then at the far extreme of this secret tunnel, the robot froze. On the screen glowed the unmistakable outline of a perfectly smooth limestone slab, sealed for millennia, and 2 gleaming copper handles protruding like a trapdoor into eternity. No one knew what lay beyond. The implication of this one shaft shows that ancient Egypt had, at the minimum, advanced surveying tools, advanced stone-cutting tools, and advanced mathematical and scientific knowledge. And it proves without a shadow of a doubt that ancient Egyptians didn't use the method proposed by conventional archaeologists to build the pyramid. First, let me describe the shaft to you. And while I describe it, I want you to pause the video and think for 45 seconds about how you would go about building such a shaft. Then write your idea in the comments and tell me how your idea would hold up against these properties of the Queen's Chamber shaft. The passage begins as a perfectly square duct only about 210 millimeters on a side, barely wide enough for a human forearm. It creeps horizontally for roughly 2 meters, then tilts upward at an incline of nearly 40 degrees and continues for some 64 meters, 210 feet, through the heart of Khufu's pyramid. Apart from a single dogleg, offset at about the 30-meter mark, and a modest 40-millimeter floor, step near the end, the passage is astonishingly straight. Later laser surveys show its walls diverge by only fractions of a degree over the entire climb. 210 feet. So for 64 meters, this shaft is so straight that you could shine a high beam through one end and you would see it intact through the other end. And you have to consider that it goes through multiple different stones and also different types of stones. Aside from a small dogleg that takes the shaft sideways for about 20 centimeters, Independent studies have shown that the walls of the shaft are so straight that they deviate by only a few centimeters over the distance of 64 meters. That is an astonishing level of precision. Even if we were to try and do this with modern tools, it would be challenging, let alone while cutting through hard rock at a 40-degree incline. Where have we seen that level of precision before? A millimeter-precise level of precision. Precision so perfect that the objects produced are so symmetrical that they can be balanced without a flat bottom. Precision so great that it would take us until the advent of 3D laser mapping to really appreciate how perfect these vessels are. The early dynastic vases are some of the only other examples of such precision on Earth in ancient history. Actually, in history, period. The robot continued until it met with the end of the shaft. At the terminus, the explorers discovered a polished limestone block, now famous as Gantenbrink's door, about 6 to 8 centimeters thick, fitted with 2 copper pins that were likely used as lifting lugs before being hammered flat and entombed for millennia. Most Egyptologists believe the shaft was either 1. A ventilation duct, 2. A leftover passageway from the construction method, and 3. Mainstream is even ready to entertain the idea that the shaft was a sacred star passage, carved course by course as the pyramid rose. Mainstream Egyptology claims that the Queen's chamber shafts were not tunneled after the pyramid was complete, but instead constructed course by course as the pyramid rose. According to this view, masons cut notches into each new block before laying it, aligning the shaft's path with simple tools like sighting rods, copper plumb bobs, and string to maintain the intended 39 to 40 degree incline. When a misaligned or oversized block intruded into the path, the builders supposedly corrected it in real time by beveling the next stone or adding small ramps and offsets. There are so many issues with that approach that it seems no efforts were made by archaeologists to actually think it through. So what's your theory? And which idea have you read that makes the most sense of how this shaft was built? Number 1, your theory has to allow for a passageway that is so straight that it is in the same order of precision as the construction of the Burj Khalifa Tower and the Freedom Tower. The tallest building in the world today, the Burj Khalifa, was able to maintain precision over its 828-meter length by ensuring that each floor did not deviate from the next by more than 18 millimeters. And to achieve this, they used lasers. Number 2, your theory has to allow for the ability of ancient Egyptians to cut this passage way through multiple hard stones while maintaining all other characteristics true. Guess how many blocks of limestone the tunnel had to go through? At least 35 to 40. So for 35 to 40 stone, alignment had to be maintained in a way that allowed for such precision to be maintained stone after stone. And that is incredibly difficult, an almost impossible feat to achieve without a continuous cutting process. And I can hear those who defend the orthodox theory saying they would have used strings and ropes to ensure the shaft remained straight. Well, while this technique would work on a flat surface to an extent, how would you make it work in 3 dimensions? But more importantly, how would you maintain that string, though 40 blocks of stones? It's just not possible. To understand how difficult the conventional approach is, try this at home. Take 30 sheets of paper and try to draw a straight line that goes through all these sheets of paper, 1 sheet of paper at a time. You can only put a sheet of paper once your line reaches the end of the sheet. Oh, one more thing. In order to replicate the fact that workers were carving these shafts 1 swing at a time, your line can only be drawn 1 short stroke at a time. There are so many issues with that approach that it seems no efforts were made by archaeologists to actually think it through.
So
Yeah,
there's
there you
an
go.
example of circular saw cut being dipped into basalt, which is harder than granite, by the way. More.
So could a normal like concrete saw, like a demo saw, cut
Sure.
through this rock?
Yeah, it could, because, well, tile saws and things like that are they're diamond tip blades. So
Right.
that's the closest analogy we have to the evidence that's in the stonework. So
Why does mainstream archaeology ignore these abundant evidences of saw marks? They are clearly there. They are clearly present. Just because it doesn't fit the current narrative of the construction of methods used by the Kemetu doesn't mean it doesn't exist.
There you go.
That's a different one, but
Okay.
that's fine. That's a good example too. That's actually a place called Abu Rawash. So you see the arc, right? There's a clear circular arc to this stone.
Yes.
So it's either a drops. It's like what you would call a swing saw or a circular saw that has cut this stone. And the one that we saw earlier that's at Abu Sir actually has a little lip at the end of it. So it's like it hasn't quite cut all the way through the stone, but there's a little like over lip that's still there from thousands of years of weathering. And through that little lip, we can tell that the blade of this thing was very thin, a couple millimeters at best.
Mm-hmm.
And when you measure out the arc of it, you're talking like 30 feet diameter, like some huge processing plant cutting this. And then you also see striations on the stone itself that shows you how that saw progressed through the stone, which was quite rapidly. Now, this is amazing evidence because you can now sort of determine the rate at which the saw progressed through the stone, which turns out to be quite rapid.
If anything, it means that our current hypotheses are wrong because they do not match the evidence. Did you know that mainstream archaeology based their theories on experiments that were done more than 100 years ago? These were done by the British archaeologist Engelbach in 1922. At the time, Engelbach estimated that the rate of granite removal using dolerite would have been 3,600 cubic centimeters per hour. Well, at the 100-year anniversary of his experiments, 2 researchers from the Slovak University of Technology decided to repeat his experiment and validate his assertions with very precise measuring of the amount of stone removed, and thus the rate of work. This is important because pretty much all mainstream explanations of how the pyramids were built are based on Engelbach's writings. Others are based on the very famous PBS-sponsored experiment done in the 1970s, where they tried to use sand and a long saw to cut through limestone. These are referenced in almost every paper on the matter, and very few are challenging these findings. The researchers from the Slovak University use photometric 3D measurement that is precise to the thousandth of a cubic centimeter, and their findings were astonishing. They found out that 100 years earlier, Engelbach had overestimated the amount of granite that could be removed in an hour by more than an order of magnitude. Where Engelbach had said that the Kemetu could remove 3,600 cubic centimeters per hour, Dr. Marian Marcish and Dr. Frastia showed that one person could only remove 216 cubic centimeters of granite per hour. This is significant because it means that wherever archaeologists had estimated that it would have taken 10 months to complete a project, measurements show that using conventionally accepted techniques, it would in fact have taken 9 years. And that's not even accounting for the fact that this approach produces an enormous amount of dust that has to be removed regularly. We should also note that Engelbach's estimates did not account for fatigue, so this further complicates the validity of the mainstream explanation. I'm not saying I know how the ancient Egyptians did their work, but I would just like to point out that current proposed methods have flaws that cannot be ignored, flaws that require us to believe in impossibilities. We are asked to believe that the Kemetu ancient Egyptians didn't have more efficient methods of cutting stones, a material that they worked with for thousands of years. We are also asked to ignore clear evidence of machining that is present throughout the Nubio-Kemetic civilization, evidence that we will review next. There is a concept that is often ignored when studying archaeology, but that concept is of the utmost importance when thinking about engineering, and it is the fact that the precision and the effort required to achieve that precision has to match the purpose. In simple terms, humans do not aim for a certain level of complexity unless absolutely necessary, and this shows all over, from precision needed for tolerances of motors, to precision needed in chemical composition for medical purposes, and even the precision needed for the instruments used to measure the same chemical components. In modern engineering, tolerance refers to the allowable variation from a specified dimension. Machining tolerance is expensive because removing material to very high precision requires better tools and more time. A survey of standard CNC machining tolerances notes that most parts are machined to within plus or minus 0.005 inch, approximately 0.13 millimeters, and tolerances below plus or minus 0.001 inch, 25 micrometers, are considered extremely challenging. Mass-produced components such as consumer products or household appliances rarely require tolerances tighter than plus or minus 0.01 inch or 0.25 millimeters. Only specialized components, such as aerospace parts or optical instruments, justify the cost of nanometer precision. For example, automotive engineers typically maintain about 0.05 millimeters clearance between a piston and its cylinder. This ensures a reliable engine without the need for microscopic perfection. Figure 2 shows a partial cross-section of an internal combustion engine. The pistons, crankshaft, and connecting rods all operate with clearances measured in hundredths of a millimeter, but not in micrometers or nanometers. Certain modern projects demand precision far beyond everyday manufacturing. The James Webb Space Telescope, JWST, launched in late 2021, required its 6.5-meter primary mirror, composed of 18 gold-coated hexagonal segments, to be aligned to within nanometers. Any misalignment would blur distant starlight and render the telescope useless. Achieving this accuracy required cryogenic testing, actuators behind each mirror segment, and sophisticated wavefront sensing software. Figure 3 shows NASA engineers installing the final JWST mirror segment. Each segment had to be precisely positioned because the telescope's purpose, to observe faint galaxies billions of light years away, demanded extraordinary optical accuracy. Why are we emphasizing this point? Well, in the two examples cited above, in the Queen's Chamber shaft with its extreme alignment and precision through hard rock, and in the early dynastic period vessels and vases, we see a level of precision that does not match the purpose described by mainstream archaeology today. Why would the ancient Egyptians require nanometer precise levels of symmetry on the vases if they could not observe or determine this symmetry with the naked eye? And to be clear, this level of accuracy does not add to the aesthetic of the vases. So when we look at it from an economic standpoint, why would ancient Egyptian nobility pay significantly more to have nanometer precise vases when the same artistic effect could have been achieved more cheaply? The same thing applies to the Queen's Chamber shaft. If the intent was to point to the celestial bodies, as is the growing accepted purpose, then you can be assured that the builders of the pyramids would have made sure the shaft did not deviate whatsoever. And yet, as we have seen at the 63-meter mark, there is a slight shift in the Queen's Chamber shaft before it continues its path upward. We should not consider this as a mistake, because if the purpose was to point to the stars, they would have made 100% sure it pointed exactly in one direction. If they were able to maintain millimeter precise alignment for 60 meters, then doing so for the additional few meters would not have been a problem. I do not know the purpose of the deviation, but what I am sure of is that it did not impede the overall purpose of what they were trying to achieve. Again, fit for purpose. This would be akin to archaeologists 4,000 years from now looking at the schematics of a Stirling engine and concluding that the precision required in the piston and power piston was for the purpose of pointing to the center of the mass of the earth. Just because we do not understand the purpose of use today does not mean that we should forego applying key principles of logic. Many theories will seem elegant, but will fail elegantly when it comes to the practicality of how the Kemetu exercised engineering and precision. So then you might ask, what is the purpose of the Queen's Chamber shaft? I can tell you what it isn't. It isn't decorative, because both from the outside and the inside of the pyramid it cannot be seen. It isn't meant to point at the stars. If that was the case, it would not deviate from its trajectory in any way. It isn't a leftover artifact of construction. No blocks can fit within the Queen's Chamber shaft, period. Also, it is too precise to be a leftover artifact of construction. If it was, we would notice a large number of imperfections, and they would not have taken such great care to ensure that the intervals between the blocks remain tight and almost invisible. It isn't a ventilation shaft as many archaeologists have proposed. Number one, the Queen's Chamber shafts do not have ends that are open to the outside. And secondly, if it is a vent, why make it so millimeter precise? It isn't a passage to a treasure. Is it an acoustic resonance device? This could be one of the possible uses. This could possibly explain the precision, but we have to note that no experiments have validated this, nor have ancient Egyptians stated so. But we shouldn't rule it out, and we should test it. And as in any machine, it has to be put within the context of the whole. So even if it is acoustic resonance, what is that resonance trying to achieve? This is where many theories have been proposed. Without discrediting any of them, they do suffer from a great lack of experimentation. If the Great Pyramid of Giza was used as a power-generating device, then I would like those who are proposing these theories to show this via experiments, even on a small-scale model. And here, the Egyptian Ministry of Antiquities has a role to play. They should provide more permits to researchers and allow them to test their hypotheses, as long as it doesn't destroy the pyramid in any way. One of the other problems in investigating the purpose of the pyramids is that we do not yet know everything about them. Recent scans show that there are still chambers or voids that are yet to be explored. This is key because, just like in the case of the Stirling engine, it would be difficult, or impossible, to deduce the purpose of the device if the top chambers, where the combustion happens, aren't known. Oh, by the way, the theory of the Queen's chamber shaft being abandoned construction also doesn't make sense. One does not spend time polishing or achieving extreme precision for a shaft that is left over. So my challenge still remains. Contact me on these social media platforms to share your idea on the use for the Queen's chamber. Do not dismiss the fringe. If the only theories we are willing to entertain on the construction and purpose of the Great Pyramid are the ones that are within the orthodoxy of our current scientific knowledge, then we are limiting our chances of understanding a civilization that had a totally different technology vector.
This guy knew how the pyramid was built. Edward Leedskalnin spent over 28 years single-handedly building the Coral Castle in Florida. What makes this feat remarkable is not just the size and weight of the stones he used, but the fact that he quarried, carved, and moved them without any heavy machinery. The stones, some weighing several tons, were cut and arranged with incredible precision. The most intriguing part of the story is Leedskalnin's claim that he knew the secrets of the ancient Egyptians when it came to manipulating the forces of the universe. He hinted at the use of magnetism and anti-gravity techniques, but the specifics of his methods remain a mystery.
It is pretentious of us in the 20th and 21st century to think that a civilization that was working with stone for thousands of years didn't have methods of working that still elude us today. Discoveries, true innovations, lie at the border and on the outside fringes of the orthodoxy. We cannot be expected to discover truly groundbreaking knowledge if we do not consider, or at least entertain and test, those theories that are today labeled as crazy. We should not be surprised that the same system which has built a mountain of lies on the true origin of the ancient Egyptians, Kemetu, that this system is today gatekeeping against true discoveries in Egypt. From the possible large structures that have been discovered by deep ground penetrating radar, to recent voids in the Great Pyramids. If you are allowed to lie about someone that has a genome that should make him look like this, but depict him as this, then what is one more lie and one more denial on the true purpose of the Queen's chamber shaft? If you have abundant statues of early ancient Egyptian kings that look like this, and you still claim that the Kemetu were of modern Levantine descent, then what is one more lie to say that they were cutting stone using primitive methods, even though there are clear machine-powered saw marks all over Kemet? The problem isn't those who are applying critical thinking to try and get to the truth. The problem is the system that wants you to abandon critical thinking and instead label and dismiss anyone else they haven't sanctioned.
Any kind of steel or other metal that you could possibly make a circular saw blade of.
A year of just grinding, and that doesn't include how they hollowed it out and everything else, just the base cuts. And when you extrapolate that to the tens of thousands, if not hundreds of thousands of granite blocks,
Now, before I tell you about what I discovered in the stone that I discovered, I want to show the whole world what I discovered. And I discovered major important things.
Are they online?
No, in my book, Giza and the Pyramids. In my book, Giza and the Pyramids.
Are there-
Kalnin worked in secret, often at night, and managed to transport and position these massive stones using his own methods. Some speculate that he may have understood certain scientific principles not widely known.
Join us and see how those who are said to be without history birth civilization itself.